All right, welcome to another micro lecture in the programming logic course. I'm your professor, Professor Fiske, and just let's jump right into it and get started. So what are we looking at right now? In this specific micro lecture, we're going to discuss what is pseudocode, what are flowcharts, okay? If you know what they are, throw the baby out with the bathwater. Forget whatever you know. If you're a PM, then never mind. But otherwise, forget what you think you know. And let's talk soup to nuts what your resident architect thinks pseudocode and flowcharts look like. Because I will tell you that I've seen a lot of things. I've seen a lot of posers. I've seen a lot of interesting situations where there are engineers who've been in the industry for a long time that have written flowcharts and pseudocode that doesn't really meet the industry standard of what we expect to see when we look at it. Now, what is pseudocode? I want to start with that. Well, pseudocode is really easy, and I have this up. I want to shout out Geeks for Geeks. They're not paying me for this, but I love using Geeks for Geeks. I love using Tutorials Point. I love using W3 Schools. I love using all the free resources that Programmees has to offer. And if I'm leaving anyone out, I'll call you out in another video, but otherwise, these are great resources for any engineer, any software engineer specifically, that wants to look at something very quickly. Like I've said in a lot of other situations, it is interesting that engineers, there are organizations that think because I'm not a C developer that I don't know how to develop in C. That's not true. If you are a real software engineer, the language is not important. The premise, the frameworks, and the way things are built are. Okay, enough about that. Let's jump into the pseudocode. We're looking at a tutorial of the C language, but in the end, nothing has really changed. So, what is pseudocode? Well, pseudocode is basically a direct reflection of the events occurring in your code. I will say it again, even though you can rewind this. Pseudocode is a direct reflection of the events which are occurring in your code. So, as I did in the last lecture, if I'm printing something to the console, then what would my pseudocode be if it's just one line? It says print, right? Let's bring up Visual Studio Code again so you can see what I'm referring to. Oh, I already closed it. So let's flip over to REPL then, and let's go to the Winding Man hypotenuse. No, it didn't. You are having a giggle. Oh yeah, no, I actually got rid of it. That is true. Well, either way, I will create a new REPL then. Or actually, no, we will go to Visual Studio Code. All right. So here I'm in Visual Studio Code, and you can see, well, you saw that at line 1, I have the command print. And print is basically a function that is built into Python, which takes the string or any other data type and converts it to a string and prints it within our terminal. So if I pressed F5, because that's my hotkey for this, and told Visual Studio Code that I am, in fact, running a Python application so it knows what interpreter to use, you can see here I'm learning how to program. That is exactly the string which is sitting inside of that print function. Now that's very important because this specific function is doing a thing. It is printing, right? So in my pseudocode, if I were to write pseudocode or an actual comment, if you will, the comment would be print, I'm learning how to program. Now, interestingly enough, they look the same. To an engineer, they look the same. But pseudocode isn't necessarily for engineers. Pseudocode is normally for business analysts, project managers, individuals who are translating our geekery, our nerdies, into something that makes sense to the business. Now, when the business sees print, in their minds, they're thinking of a printer, paper, things like that. To us, we might need to say something a little more specific when we write our pseudocode for the business, but this is the first step in that direction. Now, 9 times out of 10, if you write comments into your code in this specific context of this course, or whenever you're writing pseudocode, and you write a comment for each line of code, guess what you just did? You just wrote pseudocode. And in most situations, that is totally fine. I will tell you, after being in the industry for as long as I have, it kind of looks weird if you write comments in every line of your code. It's better if you write your code in a way that makes it relatable and understandable. So what do I mean by that? Well, the word print right here is a verb. The reason why it's a verb is because it's a function and we want the function to do something. You execute something. The function does a block of programming statements or one. So this will always be a verb. So when you write a function or a method, the name of the function or method should be a verb or a statement which is doing something. When you create your variable name, so in this case, if I created a variable, let's say I called it x equals 1 plus 1, okay, I'm a fan of white space, print x, all right, so we have line 4 is saving the equation 1 plus 1 to the variable x. We'll go into variables and whatnot in module 2, but in this case, what I want to show off is the idea that I can name my variable anything I want. In this case, I named my variable a concrete thing, a noun, all right? I'm the one that says verb and noun. I didn't learn that from anybody else. That's just my way of looking at it and kind of putting 2 and 2 together from a literary perspective. You want your functions, this is Francis's rules for writing pseudocode, or for writing code that's readable and understandable and doesn't require a lot of comments. You write your functions and your methods as verbs, a statement it could very well be a statement. If you're writing a function, you could say, def print the form. Okay, boom. Right there, we know what that method is doing. Now, I still don't like this. I can't really think of a good name at the moment, right? Normally our functions would be like string helper. That's a function that I can think of right now. But notice that it's a verb or a series of words that are inferring an action. Whereas here I can say, okay, sum, right? The sum of 1 plus 1 is 2. The variable name of sum makes a lot of sense. I can put any name there I want. As a matter of fact, I can put any series of names there, right? I can say the Taj Mahal. That's totally fine. That will totally work, right? But if I am not necessarily doing anything with the Taj Mahal in this specific reference, then I shouldn't use that as the name of the variable. I should name the variable something that matters to what's going on at this point in my code. And that would remove the need to write copious pseudocode. But in this class, you're gonna write pseudocode because AI has made this really hard to figure out what code I'm looking at. So with that being said, you can write pseudocode. That's totally fine. There's a pseudocode assignment in this module. Let's jump into flowcharts. So what in the bloody heck is a flowchart? Well, first let's talk about stack trace. Yes, sounds like I'm digressing. Let's talk about stack trace. What is a stack trace? A stack trace, okay, S-T-A-C-K, so a stack trace, all right, is the order in which your code is running relative to how it is written. All right, Francis' definition there. It is the order in which your code is running relative to the way it was written. So, in this case, Python is a scripting language, which means Python doesn't really have a stack trace per se because it's not going to stop unless you tell it to stop. It's going to run everything sequentially, right? Just like JavaScript. Now, Python is sequential, so yes, in certain respects it will wait, but it's a script nonetheless. Either way, this is the main script, right? It's going to run from the top of the script or the top of the stack trace to the bottom. You can see here on the left there's numbers, and if you throw an error, your stack trace will return to you the number and the method or function and the class where it errored out. Why? Because that's the place in the stack trace it can go no further. So when you write your flowcharts, you will also write your flowcharts from top to bottom. From top to bottom. And the reason why you will do that is because we want to mimic the stack trace. What we also want to do is ensure that our exit conditions have a way out of our flowchart. So you write from top to bottom good things, right? If everything stays in a line, that means we were on the happy path. Okay, what does happy path mean? Happy path means the path that we have taken that we wanted it to take. Okay, happy path goes from the top of the flowchart to the bottom. Okay, happy path. Notice that this is the way the stack is derived. Okay, the stack starts at the top and it ends at the bottom. Now, somewhere in between, we go from left to right based on whether we're going to another class, whether we're going to another method or function, whether we're looking at a storage location, we're executing something from a totally different library. That's totally fine. That kind of happens within the context of the flowchart, but please understand, flowcharts go from top to bottom no matter what any of your textbooks may say. All right? In the event that we have an unhappy path or we have an exception, then you will draw a line out of the stack trace, right? Draw a line and exit the program immediately unless you have written an exception to catch. If you have written something to catch that exception, then of course you can do something about it. But otherwise, no matter what you do, so in this case we're starting, and it starts with an oval, and then we have the input, we have our decision structure here, our if statement, right? That's in a rhombus, or a ruby, however you want to look at that, a diamond. And then we have our outputs. If, then, that, else, that, print at the end of it in the program. And this is really the nuts and bolts of how your flowchart really should look. So if I opened up my Lucid chart and I decided I wanted to look at the way Lucid chart does its flowcharts, you can see how Lucid chart kind of goes from left to right. When you're doing business process, notation, BPMN, that goes from left to right. When you're doing user diagrams, excuse me, it can go from left or right, depending on what's going on, depending on what actions are happening. Excuse me. I got it with the palette. But if you are representing the flow of the program, it is always top down. So I'm going to go ahead and sign in with my Google account. Lucid chart is free. It is also required for this course. Here you can see reference to architecture. What I want to look for, and I don't think I have any documents in here that I can open that would give you a good idea of what a stack trace looks like. This looks like an architectural chart. Novice, whatever. Next. Oh, I can't skip it, eh? I guess we can go with flowchart. I wonder. There we go. As a matter of fact, here goes a nice flowchart. We're going to create this document. I like this. Create the document anyway. All right. So let's kind of look at it holistically, right? We're not going to zoom in all the way. We're just going to look at it holistically. There are certain things that are going on here. This is the business process for account ownership. More than likely, an account at a normal organization, not necessarily an account at like a bank, but for all intents and purposes, you can see that how it starts at the top and it ends at the bottom. And if there are any things that need to be accounted for, they are accounted for here in the middle. The only thing I don't like is these are normally, change the shape. These are normally those. And you can see how easy it is to change the shape. It's actually quite nice. But the beginning and the end are normally pills. They look like pills or they look like ovals. If you're asking a question, right? If there's a decision which needs to be made, we use a rhombus or a diamond, all right? So in this case, they did make a mistake. I'll show you where that mistake is at the beginning. So the SDR sells a business package, okay? The account, is it owned by the AE? What does AE stand for? I'm unsure. Oh, account executive. Yes, the account executive keeps ownership of the account. Okay, great. There should be so instead of this pill being the start, what you would actually want to do, I can't drag, can I? Excuse me. Okay, cool. We'll take this and we'll put this back the way it was. Change the shape to that. Change this shape back as well to that. And then we're going to take start. Here we go. They're called terminators. Kind of like that. All right, that goes down. And then we need another terminator. Come here, please. Another terminator down here. Okay. So that's Terminator and that's Terminator. This is start. I know it's a little small. Give me a second. I will zoom back in. End. Great. Let's zoom back in. Start and end. Excuse me. Wow. All right. So in this case, this is the end, right? Wow. My apologies. Give me a second. Much better. All right. So this is the end, right? So this should actually have an arrow. It should have an arrow that goes all the way down to the Terminator. Ooh, I didn't even do that. I'm gonna have to take a break after this one. And there you go. I gotta clear out my throat. Something's going on. Either way, that's all I wanted to talk about. As I say in all my videos, good luck, have fun. Don't forget to subscribe. Like if you like it. Ciao.